Oh, hey, you guys again. I'm actually at home looking through my old high school yearbook because just like you guys, I knew I wanted to go to a top high school too. I went to Niles North. But that's not why I'm here. Today we're going to start by making an observation. I have this marshmallow and we're going to add a little bit of heat energy through the use of a microwave. So the first thing I want you to do in your notebooks is write down sunglasses and OBS because you guys are about to make an observation. On this side of your notebook, you guys are going to make sure to write down what you see as we put the marshmallow into the microwave. Remember, we're just going to add heat energy to this matter. Let's do it. See if we can look inside. Holy smokes. That is one big marshmallow. So if we take a look at the marshmallow, as we added heat, it expanded and became bigger. And as soon as we took it out, it actually got smaller. Today we're going to learn why that happens. Anytime matter gets heat energy added to it, its energy makes those particles inside that matter, those atoms, move faster and faster and spread apart, just like this marshmallow. But as we can see, as this one is cooling, it's already shrinking because the heat energy that it had that made those atoms move is going back into the air, and as it cools down, it slows down, and now this marshmallow that we heated up is almost the original size as it lost its heat energy. Whenever matter expands or condenses due to heat energy, we call that a phase change. And that's our first vocab word for today. A phase change is when we turn anything, any matter, into a new state. Our states are solids, liquids, and gases due to heat energy. We should remember phase changes from 5th grade, but I want to go over a few specific ones that we're going to hear. The first one is condensation. That's when we have a gas that loses heat energy and turns into a liquid. And if we remember what this might look like in a diagram, gas is when the molecules are moving the fastest, they have the most energy, and a liquid is when they lose a little bit of energy, but they're still moving and they can still take shape. So beneath where it says G for gas, you're going to draw a box with 4 atoms that are spread apart, and underneath liquid, you're going to make 4 molecules or atoms that are close together. That's condensation. The reverse of that, if we have a liquid and we heat it up and it turned into a gas, is evaporation. That's your next vocab word. Underneath the L, we're going to redraw our diagram of a liquid. And underneath the gas, we're going to draw those molecules that have more energy, so they're further apart. This marshmallow was still a marshmallow, even though it was bigger. All matter that goes through phase changes is still just the same matter. So phase changes are physical changes because the atoms didn't change, they just moved further apart or closer together. Physical change. The last thing we're going to write down is our phase change graph. And stay with me here because there's a lot of details to add. So the first thing you're going to write is phase change graph. Then you're going to draw your axes. And you're going to draw your line that goes up, over, up, over, up. Do that first. The next thing you're going to do is our three phases. At cold temperatures, it's a solid, then it moves to a liquid, that L, then it moves to a gas. The last thing you're going to add is what we call those. From solid to liquid, that's melting, like an ice cube when it turns from ice to water. From a liquid to gas, we call that evaporation. Going backwards, when a gas turns into a liquid, we learned today that that's condensation. And that's the reason why in your shower you might see water droplets all over. All that steam from your shower has condensed onto your mirror. And if we go from a liquid to a solid, like when we put anything in the freezer, that's called freezing. The key point to remember with our phase diagrams is that it takes a lot of molecules to change before they reach the next state of matter. So we're going to write that. That's the reason we have these flat lines. The temperature needs to change a lot so that all the molecules are now in the new phase. That's it today for phase changes. Remember, phase change just means an atom has heat energy so that it moves further apart or closer together. The atoms haven't changed, so this is still a physical change. Hope you enjoyed seeing my high school gear and my childhood home.